Exercise 1.1, question number 5. Assume that f dash of 3 equal to minus 1, g dash of 2 equal to 5, g of 2 equal to 3 and y equal to f of g of x. Then dy by dx at x equal to 2, we have to find out that. First of all, y equal to f of g of x. This is a composite function. Differentiating with respect to x with the help of chain rule, we will get dy by dx as f dash of g of x and derivative of g of x will be g dash of x. Okay. Now dy by dx at x equal to 2, in place of x we have to put here 2. So it will become g of 2 and g dash of 2. So derivative at x equal to 2 is f dash of g of 2, g dash of 2. But g of 2 is given as 3. And g dash of 2 is given as 5. Now this will become f dash of 3 into 5, but f dash of 3 is given as minus 1. So minus 1 into 5 will give you minus 5. So minus 5 is the final answer. Question number 6. If h of x equal to root of 4f of x plus 3g of x. F of 1 is 4, g of 1 is given as 3. F dash of 1 is 3, g dash of 1 equal to 4 and h dash of 1 equal to question mark. H of x is a root of the functions. Differentiating with respect to x, we will get h dash of x equal to 1 upon 2 root. Because derivative of root is always 1 upon 2 root, we have to take derivative of the inner functions, that is derivative of 4f of x plus 3g of x. Derivative of 4f of x will be 4f dash of x, because 4 is the constant thing as it is. Derivative of f of x is f dash of x. 3 constant as it is. Derivative of g of x is g dash of x. Now we will substitute the values for h dash of 1. We will put in place of x here 1. So it will become 1 upon 2 root f of 4f of 1 plus 3g of 1 into 4f dash of 1 plus 3g dash of 1. By substituting the values of f of 1 as 4, g of 1 as 3, f dash of 1 3 and g dash of 1 4, we will get this 4 4s are 16, 16 plus 9, that will be 25, and a root of 25 is 5. This is 4 3s are 12 plus 3 4s are 12. 12 plus 12 will be 24. 24 upon 2 will give you 12. So final answer is 12 by 5. Question number 7. Find the x coordinate of all point on the curve y equal to sine 2x minus 2 sine x. 0 is less than or equal to x is less than 2 pi. Where dy by dx equal to 0. Y equal to sine 2x minus 2 sine x. Differentiating with respect to x, we will get dy by dx as 2 cos 2x minus 2 cos x, because derivative of sine is always cos, but derivative of this 2x should be 2. Therefore derivative of sine 2x is 2 cos 2x, and 2 constant as it is, derivative of sine is cos here. Now we have to equate dy by dx to the 0. So let dy by dx equal to 0. Therefore 2 cos 2x minus 2 cos x will become equal to 0. Now dividing both the sides by 2, we will get cos 2x minus cos x. Cos double is 2 cos square minus 1. Okay, cos of double of x is equal to 2 cos square x minus 1 minus cos x as it is. This is the quadratic equation in cos of x. 2 cos square minus 1 cos minus 1 equal to 0. So we can have factors as minus 2 plus 1, because minus 2 plus 1 is minus 1 and minus 2 into 1 is minus 2. Here 2 into minus 1 is minus 2. Okay, no. 2 cos x common. What remains here is cos x. Here it is 1. We will take 1 outside the bracket. What remains is cos x minus 1. Now cos x minus 1 is common. What remains here is 2 cos x plus 1. Cos x minus 1 equal to 0 or 2 cos x plus 1 equal to 0. Minus 1 will go to that side, become plus 1. we know that cos 0 is 1 or cos 2 pi is 1. Therefore, x should be 0 or 2 pi. Now, here it will be plus 1 will go to that side and become minus 1 into 2 will become upon 2. Cos x is equal to minus 1 half. Minus as it is, we know that 1 half cos of pi by 3 is 1 half. Now we will use the result. Cos of pi minus theta is always minus cos theta. What is the result? Cos of pi minus theta is always minus cos theta. Now we will simplify this pi minus pi by 3. 3 pi minus 1 pi, that is 2 pi by 3. So x should be equal to 2 pi by 3. Therefore, final answer here is x equal to 0, x equal to 2 pi by 3 and or x equal to 2 pi. Question number 8 is homework for you because it is the activity based question, should be solved by students. Now question number 9, sorry, it is exercise 1.2 now. Question number 1, find the derivative of the function y equal to f of x using the derivatives of the inverse function x equal to f inverse of y. Now, y equal to root of x. For getting inverse function, we should find out x in terms of y. We first find the inverse function y equal to f of x, that is x in terms of y. y equal to f of x चं डेरिव्हेटिव्ह आपण इन्व्हर्स फंक्शन घ्यायचं, म्हणजेच x इन टर्म्स ऑफ y आपण इंटरप्रिट करायचं. सो to get rid of this root, we will square both the sides. Y square equal to x. So x equal to y square. X is nothing but f inverse of y, that is y square. Therefore, dy by dx, according to the theorem, dy by dx is always equal to 1 upon dx by dy. That is 1 upon derivative of what is x. We interpret x in terms of y square. So we will place in place of x y square. Derivative of y square with respect to y is 2y. Now in place of y we can put this root x. So dy by dx is 1 upon 2 root x. We have found this derivative by using inverse function. Directly also we can check the answer. Derivative of root x 1 upon 2 root x. Okay. Now Roman 2, y equal to root of 2 minus root of x. We shall first find the inverse of the function, that is x in terms of y. Squaring both the sides we will get y square equal to 2 minus root x. Minus root x will come to this side and y square will go to that side. Now once again squaring both the sides we will get x equal to 2 minus y square bracket square. Okay. Now that is x is f inverse of y, which is equal to 2 minus y square. We know that dy by dx is equal to 1 upon dx by dy according to the theorem. What is x here? X is 2 minus y square bracket square. We should differentiate it with respect to y here. Okay, no? So derivative of this bracket raised to 2, that bracket raised to 2, that 2 will come down and power will decrease by 1. Then it will become 2 in bracket 2 minus y square. But we have to take derivative of this y square as 2y. Now we can place in place of this y square, we can substitute that y square by 2 minus root x. Here y square is 2 minus root x. Okay, see here. And this y as root of 2 minus root x. Y as root of 2 minus root x. This 2 and this 2 is as it is. Now this minus sign, we change the sign, 2 minus 2 will get cancelled, minus minus will become plus. That is root x. 2 2s are 4 times root x into root of 2 minus root x is the final answer. So Roman 3 is y equal to cube root of x minus 2. We first find the inverse of the function y equal to f of x, that is x in terms of y. Taking cubes on both the sides, we will have y cube as x minus 2. Minus 2 will come to this side and will become plus 2. Then x is nothing but y cube plus 2. X is f inverse of y, that is equal to y cube plus 2. We know that dy by dx is always equal to 1 upon dx by dy. But what is x here? X is y cube plus 2. Differentiating with respect to y, this derivative of y cube is 3y square, derivative of constant is 0. Now y square is, see here, this y square is x minus 2. Therefore, we can put this y square as, we should put y in instead of y square, we should put y here. Let us check what is the value of y here. Value of y is cube root of x minus 2. See here, value of y is cube root of x minus 2, bracket raised to 2. That means 1 upon 3 x minus 2 raised to 2 by 3 also you can write. Okay, this is the final answer. Okay, now Roman 4 is y equal to log of 2x minus 1. We shall first find the inverse of the function y equal to f of x, that is x in terms of y. For that, see this result, log of a to the base b is always equal to, log of a to the base b equal to x. Then we should write b raised to x equal to a in the index form. Okay, no? Same thing here. If y equal to log of 2x minus 1, what is the base here? Base is e. Then we should write e raised to y equal to 2x minus 1. This minus 1 will come to this side, will become plus 1. So e raised to y plus 1 equal to 2x. X equal to e raised to y plus 1 upon 2. X is nothing but f inverse of y. F inverse of y is e raised to y plus 1 by 2. Dy by dx, we know that by theorem 1 upon dx by dy. What is x here? E raised to y plus 1 by 2. Now we will take derivative of this function. 1 by 2 is the constant thing. Derivative of e raised to y is e raised to y. We know that e raised to something, derivative of that is e raised to that thing. Derivative of 1 is 0 because it is a constant. This 1/2 will go up and will become 2. Then 2 upon e raised to y. But what is e raised to y here? E raised to y is 2x minus 1. See here, e raised to y is 2x minus 1. Therefore, 2 upon 2x minus 1 is the final answer. Once again, y equal to 2x plus 3, we will convert this in that x in terms of y. We will interpret the function as x in terms of y. Then y minus 3 by 2 is x. X equal to f inverse of y, that is y minus 3 by 2. Dy by dx is always equal to 1 upon dx by dy by theorem. Derivative of this x, what is x here? Y minus 3 by 2. This 1/2 is common. Derivative of y with respect to y is 1. Derivative of 3, constant thing, it is 0. Now 1/2 will go up and it will become 2 by 1, that is 2. Roman 6, y equal to e raised to x minus 3. We shall first find the inverse of the function y equal to f of x. That means minus 3 will come to this side and become plus 3. Y plus 3 is equal to e raised to x. Now, if b raised to x equal to a, then taking log on both the sides, we can have log of a to the base b equal to x. See here, log of a to the base b. Log of a to the base b equal to x. We will do here same thing. that is e raised to x equal to y plus 3, then log of y plus 3 to the base e should be equal to x. See here, log of y plus 3 to the base e equal to x. So x equal to log of y plus 3. That is the inverse function of y. Now dy by dx, we know that by theorem 1 upon dx by dy. What is x here? Log of y plus 3. Okay, no. Now derivative of log of y plus 3 we have to take. Derivative of log of something, 1 upon that thing. And derivative of y with respect to y is 1. This 1 upon y plus 3 will go up in the numerator and will become y plus 3 upon 1. What is y plus 3 here? Let us check. Y plus 3 is equal to e raised to x. Next question is question number 7. Y equal to e raised to x. Same thing we will do. If a raised to x equal to y, then log of y to the base a is always equal to x. Here also, if y equal to e raised to 2x minus 3, then log of y to the base e is equal to 2x minus 3. Now this minus 3 will come to this side and will become plus 3. This into 2 will become upon 2. Then x should be equal to log of y plus 3 by 2. See here, x is equal to log of y plus 3 by 2. This is the inverse function. Differentiating with respect to x, we will get dy by dx is equal to 1 upon dx by dy according to the theorem. Then what is x here? X is log of y plus 3 by 2. Derivative of log of y is 1 upon y. Derivative of 3 is 0. This 1/2 constant along with variable is as it is. And derivative of constant is 0. But derivative of constant along with variable is as it is. Okay. Now this 1 upon 2y will go in the numerator and will become 2y upon 1. 2 as it is there. What is y here? Y is e raised to 2x minus 3. Okay. Now Roman 8, y equal to log of x by 2 to the base 2. We shall first find the inverse of the function y equal to f of x. Then 2 raised to y is equal to x by 2. According to the index form, we will have 2 raised to y equal to x by 2. This 2 will go up. Then x should be equal to 2 into 2 raised to y. That is 2 raised to. Addition of this power will give you 1 plus y. Okay. So x equal to f inverse of y equal to 2 raised to y plus 1. dy by dx is equal to 1 upon dx by dy according to the theorem. Now what is x here? X is 2 raised to y plus 1. Now derivative of a raised to x is always a raised to x into log of a. Similarly, derivative of 2 raised to y plus 1 is 2 raised to y plus 1 into log of 2. But derivative of y plus 1 we have to take derivative of y is 1. So no change will be there. Now what is 2 raised to y plus 1? 2 raised to y plus 1 is x. So final answer is 1 upon x log of 2. Now question number 2. Find the derivative of the inverse function of the following. Roman 1, y equal to x square e raised to x. Differentiating with respect to x, what we will get? Dy by dx x square. Derivative of e raised to x plus e raised to x, derivative of x square. What is this? First function as it is, derivative of second one, plus second function as it is, derivative of first one. X square as it is, derivative of e raised to x is e raised to x. E raised to x as it is, derivative of x square is 2x. Now we will take out this x e raised to x common. What remains here is x plus 2. Okay. But we have to find out the derivative of inverse function. Derivative of inverse function of y is always dy by dx, 1 upon dy by dx. How it is? See here. So dy by dx is equal to 1 upon dx by dy. Therefore, dx by dy should be equal to 1 upon dy by dx. Okay, but what is x? We know that if y equal to x, then x should be equal to f inverse of y. So in place of x, we can write here derivative with respect to y of f inverse of y. That is equal to 1 upon dy by dx. Therefore, if we want to take derivative of inverse function, then that answer should be equal to 1 upon dy by dx. Okay. So here also derivative of inverse function, that is equal to 1 upon dy by dx. Dy by dx we have already calculated. It is x e raised to x plus 1. Roman 2, y equal to x cos x. Differentiating with respect to x, as usual we will get this answer. Now derivative of inverse function is 1 upon dy by dx. Each time you have to mention this, that dy by dx is equal to 1 upon dx by dy. Therefore dx by dy should be equal to 1 upon dy by dx. But what is x? As y equal to f of x, therefore x is f inverse of y. Therefore in place of x we can write here f inverse of y, and therefore we can conclude that derivative of the inverse function is 1 upon dy by dx. So it is 1 upon minus x sin x plus cos x. Differentiating Roman 2, y equal to x into 7 raised to x, differentiating with respect to x, what we will get? Dy by dx, first function as it is, derivative of second one, plus second function as it is, derivative of the first one. X as it is, derivative of a raised to x is a raised to x into log of a. Therefore derivative of 7 raised to x is 7 raised to x into log of 7, plus 7 raised to x as it is, derivative of x is 1. 7 raised to x taking out, in bracket we will have x log 7 plus 1. We know that derivative of the inverse function is 1 upon dy by dx. That is equal to 1 upon 7 raised to x, x log of 7 plus 1. All the problems are similar. That is, derivative of the inverse function is always equal to 1 upon dy by dx. Each time you have to differentiate with respect to x, we will get dy by dx, and then we will say that derivative of the inverse function is 1 upon dy by dx. This is the calculation. Roman 5 is the homework for you, or rest of the problems are homework for you. Thank you very much. Thanks a lot.